Okay, in this video, we will discuss continuity, discontinuity, and different types of discontinuity. So first is what do we mean by continuity of a function at some point x is equals to c? So if you have a function f of x, so it is continuous at x is equals to c if the function is defined at that particular point, means it's not undefined or infinity, and then the left hand limit and the right hand limit, that both are the same, means that the limit exists at that point. And the final condition on that is that the limiting value and the function at that particular point, if they're both the same, then this is called that this then we say that the function is continuous at that given point. And there are a few types of discontinuity. So this function, if you have a function f of x and the graph of this function is of this form, means there is a hole in it. So this function is discontinuous at x is equals to c, because the function here is not defined. At x is equals to c, the function is not defined, so you said that this function is not continuous. So the first condition was that the function has to be defined at that point, and it's not defined, so this is not continuous. Another is if you have a function described, the graph is described in this format, you can see that if he approaches to c, the limiting x approaches to c, from left side the value is this one, and from right side the value is this one. So they're not both the same, which means the left hand and the right hand limit are not both the same, which means the limit does not exist. So if that is the case, this is called jump discontinuity. And then if you have a function of this type, that if you approaches c from left side, it gives us positive infinity, and if you approaches to c from the right hand side, it approaches to infinity, positive infinity, then we call this as infinite or infinite discontinuity. And finally, another type is called removable discontinuity, right? And this is because when the limit exists, right, but it's not equals to the function at the particular point. So we can see that the limit exists at x is equals to c, the left hand limit and the right hand limit are both the same, is equals to this point, and the function is defined at this point. At c, the function gives you this value, so they're both defined, but they're not both the same. So this is called removable discontinuity. It means you can remove this discontinuity by putting the function equals to this value. Okay, now from question 11 to 22, they're asking you to find out if there are any x values at which the function is discontinuous. So question number 11 says that you have f of x is equals to 5x to the power 4 minus 3x plus 7. You can see that this is a polynomial, and all polynomials are continuous. So there is no x. So you can say there is no x at which the function is discontinuous because this is a polynomial. And this is continuous on all real numbers. Similarly, the second question, 12, says the cubic root of x minus 8. Since inside the cubic root you can put any value and it will be defined, so there is no x for which this function can be discontinuous. So it is continuous for all real numbers. 13, we can say that if you have x plus 2 divided by x squared plus 4. So in short form, if you have a function of this form, then if you put the denominator, whatever is in the denominator, it should not be 0. So at which all those points at which the denominator is 0 would be the discontinuous point. So whatever, if you are given a function of this type, what you have to do is you put the denominator equals to 0, find out all the values, and all those values of x, at all those values of x, the function would be discontinuous. So if you look at this function, x squared plus 4 is a is in the denominator. So can x squared plus 4 be 0? If you look at this one is x squared and you're adding something to it, so it will not cancel each other. So you can see that we can write this as x squared is minus 4, and that is never possible. You cannot have a square equals to negative number. So it means this is also, there is no point, there is no x at which this function can be discontinuous. So we go to question number 14, and it says that x plus 2 divided by x squared minus 4. Again, the denominator is this one. You put the denominator equals to 0. Now it makes sense. X squared is equals to 4, which means x is equals to plus minus 2. So we have x is equals to plus minus 2 at which this function is discontinuous, right? Question number 15 says that f of x is equals to x divided by 2x squared plus x. Again, you put the denominator, which is x squared plus equals to 0. We can take x common, so 2x plus 1 is equals to 0. This implies that x is equals to 0 and 2x plus 1 is equals to 0, which means 2x is equals to minus 1, which means x is equals to minus 1 over 2. So you have 2 points, these ones at which the function is discontinuous. Question number 16, as you can see, again, you have a denominator, x squared plus 4x plus 5 is equals to 0. Can we find an x? You can see that either you can factorize it or you have to use the quadratic formula. So if I use quadratic formula, a is equals to 4, b is equals to 4, c is equals to 5. The quadratic formula says that minus b plus minus b squared minus 4ac divided by 2a. So x is equals to minus 4 plus minus, if I put b as a 4, 16 minus 4 times 4 is 16 times 5 is 80, and the 2 times 4. And you can see that this is something negative. So minus 80 plus 16 gives you negative inside the square root, which is not possible. We going into the imaginary value, so there is no x value for which this function is discontinuous. In this one, you can see that we have addition of two functions. So what you can do is this function is discontinuous at x is equals to 0, and this one is discontinuous at this x squared minus 1 is equals to 0, which means x is equals to x squared is equals to 1 and x is equals to plus minus 1. So you have 3 points, x is equals to 0, x is equals to 1, and x is equals to minus 1 at which this function is discontinuous. If you go to question number 18, it is in the similar fashion, 5 over x and 2x divided by x plus 4. Again, where is this function discontinuous? At x is equals to 0, this is discontinuous, and x plus 4 is equals to 0, which means x is equals to minus 4. So you have these 2 points at which this function is discontinuous. Question number 19, the denominator is this one. So x plus the modulus or absolute value of x plus 3. Can this be 0? It cannot be 0 because this is always a positive value and 3 is a positive. So addition of positive number cannot be 0, right? So there is no x value at which this function is discontinuous. Now if you look at this one, the mod, the absolute value, and has some value inside. So the inside one, this cannot be discontinuous, but this can be discontinuous at this point. So x4 plus x is equals to 0. If you take x common, x3, x power 3 is equals to 0, which means x is equals to 0, and x3 plus 1 is equals to 0, which means x is equals to x3 is minus 1 and x is equals to minus 1. So you have these two two values at which the function can be discontinuous. Now it's a piecewise function, and now we can find out that the three conditions. We have to find out the function is defined at x is equals to 4. So when x is 4, this is the equation. So you can put the value in it, and you can see that the value is 11. Now you have to find out the left-hand limit. When you approach to 4 from negative side, from left side, so this is the function 2x plus 3, and if you put the values, this gives us 11. Now we have to find out the limit from the right hand side. The right hand side is this one, so we have to put the values x. Now apply the limit 16 over 4, and that gives you 4 plus 7 is again 11. So you can see that the limit x approaches to 4 from negative is the same as x approaches to 4 from the positive is equals to limit x approaches to 4, and that is the exact same value at f of 4. So this function is continuous, so there is no x value at which this function is not continuous. Now we can see that the function at 3, again you have to find out, at x is equals to 1, the function is 3. Now we have to find out whether the limit when x approaches to 1 from positive side, or you can say from negative side first, of f of x is x approaches to 1 from negative side. We have 3 over this one, and we put the values. This gives us negative infinity, and when x approaches to 1 from positive side, f of x limit x approaches to 1 from positive x minus 1. When you apply the limit, it gives us positive infinity. So the limit does not exist at x is equals to 1. So the function is not continuous at x is equals to 1. Now, one thing that how did we get this thing is a positive or a negative? You can look at this from the graph of the function. So this is 3 over x minus 1. So if I say that if I have the graph of this one, then we can see that the graph of this one is of this type, right? So you can see that if you approach to 0, from this side it's negative infinity, and from positive side it's positive infinity. So if you subtract something from here, this moves a little bit in one direction. So the graph would be at 1, and then this one. So you can see it just moved a little bit, but the rest of the graph is the same. So when you approach from this side, it's negative infinity, and if you approach from that side, it's positive infinity. So the limit does not exist. I hope you understand these problems. Thank you very much.